Welcome to my session. Myself, Dr. Kode Jaya Prakash, working as Senior Assistant Professor in Department of Mechanical Engineering at VJEC. So now today I'm going to discuss about the STL file and its issues in additive manufacturing. STL file, and what is the STL file, what is the purpose of STL file, and how the STL file plays an important role to transfer the data to the additive manufacturing machines. So related to all STL issues I'm going to discuss today. So now let's start with 2D printing. Now, what is the input required, which is required to print any sort of matter on the A4 size sheet? So this input, how this input plays an important role, and what are the instructions to be given to print that a printer, general ordinary inkjet printer. So right from this, I'm going to tell about this 3D printing, right from 2D printing to 3D printing. So now, when you take the case of this of this 2D printing, now what is the data interchange? So generally, if you want to print any document, or if you want to print any Word or any PDF file or any sort of thing, PostScript is required. Means that it is a stack-based programming language where the set of instructions is given to the inkjet printer. So as these alphabets are going to be given as input to the printer, based upon that it is going to generate the alphabets to be printed on the paper. Similarly, just like that, the concerned PostScript data interchange format, STL file is also a standard file format where the set of instructions is given to a 3D printer. You can see here. So here, instead of document here, the CAD model is converted into .stl. And then this STL stands for Standard Triangular Language. So I will explain what is the triangular language, why we are going to choose the triangular language later. So here the CAD means that whatever the geometry we are going to do in the CAD files, whether you use CATIA or Fusion 360 or Creo or any sort of CAD modeling software, your geometry is going to be encoded in the form of STL. So this STL is going to be splitted into several set of instructions in the form of a codes. So as per the codes, the printer is going to start lay up the material. So there in the PostScript, only so you can't feel the XY and axis, only you can see the alphabets. But here the Z dimension is going to be added so that you can feel the material. So this is the difference between a PostScript and the STL file to be given to a 3D printer. Now coming to the case of this STL file printing, we are going to do from a digital file is going to be used to print a physical object. This is a specialty of a 3D printer when you compare with the inkjet printer. So inkjet printer, exactly, you can't feel the alphabets, but here a 3D printer you are going to feel the alphabets because X, Y and followed by Z direction is going to be added so as the material is going to be filled. So here you can see here, based upon that, the process chain is also going to depend upon that. So first we need to take the CAD model and then we need to convert into .stl, and then we need to transfer the file to the machine, and we need to define all the build parameters, what are parameters which are required, and then the object is going to build, and then we need to remove the part which is printed, and then we need to finish the excess material which is required, that is a post process, and then follow with certain applications. So this is a sequence of process chain to be followed for this based upon the STL file instructions. Now, what are the STL file? What is this STL file is going to consist of? We are going to see now. So STL is a globally acceptable file format for any additive manufacturing machine, whether it is a polymer, whether it is a metal, or whether it is a sort of liquid-based AM process, or whether it is a sheet-based AM process. For any file format, the STL is a globally acceptable file format. Now, coming to the case of STL abbreviations, what are the different abbreviations we can able to call it STL? It can be also called as stereolithography and a standard triangular language and standard tessellation language. And here, so as I told you, the main purpose of the STL file is to encode the surface geometry. Means that all the set of information is going to be tiled by the series of triangles. That is called as a simple word that is called as tessellation. Similarly, what STL file is going to consist of? STL file is going to consist of vertices, edges and faces. That is, vertices means it's the points, and we can able to call it as edges means it's the lines between the points, and faces means the surface between the lines. So each triangle is going to have the normal vector, which means that the side of a triangle faces outward. So here a STL file, it is an basically it is an approximation of the original design and contains the information of both the inside and outside of the part. Now, so here this STL, as you can see this is how the STL file looks like. So your entire CAD geometry is going to convert into STL. So that STL is going to be tiled by the series of triangles. That is what it is called as a tessellation process. Means it's a tiling of the surface, means one or more geometrical shapes such that there are no overlaps and gaps. So means that simply if you take a floor, so the floor is going to be covered with certain tiles. So each tile is going to define its surface geometry. Just like that, the STL file also is going to define its surface geometry after tiling the entire surface. As you can see you can see in the figure, this is a CAD model, and inside that your CAD geometry is going to be encoded. That is called as STL model. So it is a two-dimensional outer surface of a 3D models using with a tiny triangles. So these tiny triangles is also called as facets. So it is going to store information about the complete file. Now, what are the requirements to generate for STL file? So that is vertex to vertex rule and a right hand rule. So means that the data about the triangle vertices must be stored in the file so as to identify interior and exterior surfaces. That is the main purpose of STL file as per the right hand rule. Whereas vertex rule is that a triangle must share exactly two common vertices. So with each adjacent triangle, you can see these two common vertices. So if this pattern is not going to lay, means this entire geometry is going to be gets disturbed, and also so this orientation, if it is not maintained, it is going to confuse the AM machine to lay up the material. You can see here why only this triangles file is going to be used. Why not different polygons? Because our polygons are different polygons will be there, the rectangle, hexagon, pentagon, octagon, etc. Why we are going to choose only a triangle rather than all this? So means that a triangle is a simple polygon where we can able to split the complex shape into multiple parts. A simple example is that a square and the rectangle consists of two right triangles. A hexagon can be made up to 6 equilateral triangles, and octagon can be made up to 8 isosceles triangles. So that is the reason why simply it is having the two vertices and one normal. That is the reason why this triangle is going to be a preferred polygon to tile the entire complex surface geometry. That is why this triangle is going to be chosen, and it is called as a standard triangular language. So in this pattern, so this triangle is a simple polygon where you can able to is going to occupy the entire complexity of the geometry. As you can see this simply in the case of that every engineer, because we are all fond of the integral calculus. So this integral calculus is going to explain you how the functions are to be performed and how to describe an area under complex curves, etc. So these complex curves are mainly we are going to use triangles or rectangles which can be converted to triangles under the curves and summing up of all these calculations. So that is the reason why this integral symbol looks like an enlarged S. So fundamentally this CAD software is going to perform the complex integral calculus to best describe the complex surfaces of an object and under binary manner, so that your complex robot of a 3D printer can be able to understood easily with the complexity of the file we are going to use. And this triangular surfaces, you can see this polygon or 4 more sides can be divided into triangles, and on a computer there are representing the list of these 3 corners for each triangle. A vertex is described by x, y and z coordinates. We are going to see in the coming figure. As you can see this, so this is the reason why this triangle is going to be preferred when you compare with all the polygons. You can see this sort of polygon can be divided into comfortably 2 triangles, and 5 sides can be converted into 3 triangles, and 8 sides can be converted into 6 triangles. So this is the reason why a polygon can be able to split by easily with the triangles. So that is why this triangle is going to be preferred, and it is called as triangular language. You can see, so as soon as that complexity of the split up is done, and you can see that many triangles that allow this complex detail. So each triangle is going to give the details of the surface geometry. So that is the reason why. So this triangle is going to be used to complex the entire surface geometry. So now in the case of a triangular in space, and each vertex has x, y, z coordinates, you can see here, and listing vertices starting with any of the 3, and just like a counterclockwise, as you can see from outside. So you can use either just a normal vector, and you can use the right-handed x, y, z axis. As you can see this left-handed Cartesian coordinates and right-handed Cartesian coordinates, because this Cartesian coordinate system is going to be mostly depend upon the STL file. You can see the example of a simple tetrahedron where you can see this all the faces are having equilateral triangles, tetrahedron, where you can see that A, B and C and D coordinates, so we can able to easily split up the complex shapes. And now what are the issues that are going to be worked out for STL files? Because the converting into CAD to STL file is a simple task, but to understand the issues and how to overcome the STL issues is a very important task, so that we are going to get the exact part to be printed. So first and foremost issue is that holes or gaps in a mesh. This triangular mesh is going to consist of holes or gaps. So simply I can say that it should be a watertight model. Means it should not have any sort of leaks, etc. So this errors occurs especially when the adjacent triangles fail to share the 2 common vertices. So if this error is overlooked, the printer cannot be able to lay up the material. So it is going to lead to the print failure. So we have to ensure that the holes or gaps should be completely closed, and that a mesh should be completely closed. A mesh should be completely oriented. This is the first and foremost issue, common issue, where we are going to find it for the complex geometrical structures. And second issue is that flipped normals. Flipped normals is that, so occasionally the normal vector faces in the reverse direction. So means that this if the normal vector faces to the reverse direction, so this is going to lead to confuse the printing process. So there the material is not going to lay properly. So a flipped normal, especially the 3D printer, has difficulties in identifying the inside and outside of the model, so which cannot be accurately sliced. So what is a slicing? I'll tell you in the coming slides. And this is a flipped normals, and sometimes most of this inverted normal which confuse the printer, as I told you, that inside and outside of the model. So for additive manufacturing, each triangle in the STL file should have the correct normal vector. So if it faces to the opposite side, means the printer is going to fail, and that metal is not going to lay properly by the printer. As you can see this, next is the intersecting and overlapping triangles. So this errors occurs mostly when you are going to choose the complex geometry. So complexity of the internal geometry mostly. So this internal geometry doesn't take too much effort to repair such an error. So it can be corrected. Only this will be mostly we have to go to the CAD files to sort out the issues. So to avoid a failed print, so we need to remove or unify these triangles with the file repair software. So though if you go and work out on the CAD software sometimes, so it won't get sorted out. So these issues can be solved, especially we are going to use the STL repair softwares. I'm going to tell you later what are the STL this open source softwares we can able to work out with it. So, and next issue is that bad edges. You can see that the edges of the triangles are not properly connected. You can see these gaps. So these gaps are going to result for the bad edges. So this patching and blending of the bad edges with the and we are going to use the dedicated software tools to repair the bad edges, because it should not consist of any gaps. So gaps means that proper laying up of the material is going to happen. Next is the noise shells. So what is a shell? Shell is the outer layers of the print on the outside of the model. So the higher the shells, the denser the outside walls. So that when a shell gets too small, it becomes redundant and serves little purpose. Such shells are called as noise shells. So these noise shells also should be removed completely. So especially, so this issue is going to happen only with the flipping of the inverted triangles. Next, we are going to see what are the STL repairing tools. So Autodesk NetFab software, we can able to completely repair our STL files, and followed by Mesh Mixer is also from the Autodesk, and the 3D Builder from the Microsoft Core, and Make Printable for the Make Printable option. So these are the different open source softwares where you can able to work out on the complex geometries for the STL repair issues. So what are the STL types of formats? We are going to have the two formats. One is ASCII format and other is a binary format. So which format is going to be suitable? So finally, if you are going to use for additive manufacturing, this ASCII format, this binary format is always recommended for this 3D printing, because binary format size is very less. You can able to use comfortably for the 3D printer. But whereas for ASCII file format, especially is going to use to work out for the algorithms. If you want to work out for algorithms, or if you want to change any sort of things, or if you want to you can able to work out on this AML, or if you want to check with that sets of data sets, if you want to do for multiple iterations, then you can able to select this ASCII issues, the ASCII STL file format. So then what is meant by slicing? So slicing is a tool especially that is going to needs to convert a 3D model into printing instructions. Means that for example, if you take the simple apple, this apple is going to be sliced into layer by layer. So each slice is going to be given to generate the tool paths. Means that how to lay up the material, and going to calculate the amount of material to be extruded to be printed. You can see all the layers are going to be laid up simultaneously till the completion of all the layers. So this slices means that the layers are called as slices. Now, what are the advantages of STL file? So it is easy conversion. So it means that the STL file format is very simple and it contains only planar triangles, and wide range of input is we can able to see, and simple slicing algorithm. So algorithm can be sliced in a very simple manner, as it can able to very easily to process the list of triangles. And ability to split the models. We can able to split the model, complex models, into a number of submodels. And what are the challenges of STL file? We can duplicate information, and leaks and inconsistency is a common issue. And if it does not scale well, so high resolution lattices issues is going to happen, and it does not support color, materials, and orientation. So means that we can't give it a color, we can't give it a metal properties, and suppose in different orientations we can't do it. So now all these issues what I had listed here means the duplicate information and scaling issues, and if you want to add the metal properties and orientation, these problems can be solved in only one and only file, that is called as AMF file. So additive manufacturing file. Very soon, in the additive manufacturing file is also there now. So still some research is going on for implementing this AMF file. So all these issues can be solved in additive manufacturing file. In the coming days, our STL file is going to be replaced by AMF file. So what are the functions of this for this AMF file we are going to see? It is a meta format, and format of the formats means that is a XML format. So it is easy to write and read and parse, and also existing editing tools and extensible and high compressible tools. And what is the general concept? We can able to, so volumes can be defined by triangular mesh. So color properties can be specified, and materials also can be combined, and objects can be combined into constellations. Means that repeated instances, packing and orientations can be done using this AMF file. This is how this basic structure of the AMF file and the syntax is going to see here. So this AMF file, we can able to define the color, we can able to define the metal properties, etc. So all these issues we can able to solve in this AMF file. As you can see here, how the compressibility of file can be is going to be shown with compared with the STL versus AMF file. You can see this ASCII STL and binary STL. You can see the AMF file is comparatively very low, and ASCII and binary compressed is and AMF is so much of because you can see much amount of data can be stored in the AMF file. You can see here, so number of triangles and binary triangle uncompressed, binary triangle compressed, and AMF uncompressed and AMF compressed. So all this data, this table you can able to show. So how best the AMF file can be compressed. So it can be stored either as text or compressed, and both versions have AMF extension, and thus that reader can determine which and decompress that during read. Can see thus increasing geometrical accuracy. These curved surfaces and microstructures can be able to work out on this AMF file. So typical objects requires millions of triangles and are likely to get worse with increase in printer resolution. You can see the multiple materials. So multiple materials can be added to understand this AMF file. We can able to work out on this metal properties and multiple materials also. So these are the details which is required for the STL file, and the most important points which are going to be keep in mind, especially we are going to work out with complex geometries, and these are the essential things which we are supposed to know about the STL file before going to the additive manufacturing parts. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.